Alright, our goal here is to be able to verify some trig identities. What an identity is just an equation that's always true no matter what you stick in it, as long as what you stick in it is in the domain of that function. So the first kind of identities we have are cofunction identities. In trig, we have sine and its cofunction is cosine, tangent, its cofunction is cotangent, and secant with its cofunction of cosecant. And for complementary angles, for cofunctions, they're exactly the same. So basically the reason why is this. If I have myself a right triangle, let's call this one theta, then that one up there is going to be 90 minus theta. And in terms of opposite and adjacent, there's the hypotenuse, there's the opposite, there's the adjacent. If I'm looking at sine, sine is supposed to be the opposite over the hypotenuse. But if I switch angles and I look at the 90 minus theta, now the opposite and the adjacent switch sides. So now this one becomes the opposite and this one becomes the adjacent. So notice that I get the same exact ratio. So that's why those things work, either in degrees or in radians, pi over 2, complementary angles. Then we have our reciprocal identities. So each of the old trig ratios that you remember from geometry, sine, cosine, and tangent, all have a reciprocal, and the reciprocals are all of the new ones. We have cosecant, secant, and cotangent. The easiest way to remember which one goes with which is that in each one of these pairs, there's only one c. There's only one c. Okay, then we have our quotient identities that tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. These should make sense since that is the reciprocal of tangent. So I just remember one, that it's sine over cosine, and to get cotangent, just flip it over. Hi, baby. And then the last set of identities are the Pythagorean identities because they are based on the Pythagorean theorem. Sine squared plus cosine squared equals 1. And what this means is you take the sine of whatever your angle is and you square it. We like this notation better just because it might be confused with the theta that's being squared, and that's just dumb. So we put the little square on the side. The other two Pythagorean identities are just basically derived from that. We got 1 plus tangent squared equals secant squared, and 1 plus cosine squared equals cosecant squared. So these are often used in substitution, so I can transform an identity from one form into another. So sometimes you have to transform this equation. For example, I might want just sine squared by itself. That will be equal to 1 minus cosine squared. And I can do something similar on those two. Alright, let's try a pretty simple identity to verify. Now when you verify these identities, you don't treat this like it's an equation. You don't try to get something from the left side over to the right side or vice versa. You're just working on one side, and this says left, transform it to make it look like the right side. So think of the equal sign like a wall that we can't cross. Okay, so we're just going to do some substitution with stuff over here on the left side, and then whittle it all down to make it look like the right side. So I've got a cosine over here is what I got to make this look like. Cotangent times sine. Well, I know that cotangent in terms of sine and cosine is cosine alpha over sine alpha. So all I've done is I've just substitute that in for cotangent, and now still multiplied times the original sine alpha. And now this is just a straight multiplication problem, and these two things divide out, they cancel out, leaving me with the cosine of alpha. And it checks out, so it's verified. Alright, stay tuned for a couple more problems.